For 41, we want to find the standard form of the equation of a parabola with the parts. So in A, we're given that we have a parabola with a vertex at 0, 0. I always suggest drawing a little picture so we can see what's going on. So we have a vertex at 0, 0. And we have a focus at negative 6, 0. Since our parabola always eats our focus, we have a sideways parabola facing negative 6. Therefore, we want to make sure that we write our equation in the form of y minus k squared equals 4p x minus h. So since our h and our k are 0, 0, 0 because of our vertex, we have y squared. And p is the distance between the vertex and the focus, so the distance is negative 6. So we'll have a value of negative 24 and then just x. For number 2, we have a vertex at 2, 3. And we have a directrix at y equals 7. And our directrix is always a line, and in this case it's a horizontal line since it's a y equals. And our parabola always faces away from our directrix, so we know that our parabola will be facing down. So since our parabola is facing down, we know that we will be writing it in the form x minus h squared equals 4p y minus k. And p is the distance between the vertex and the focus. It's also the distance between the vertex and the directrix. So our equation will be x minus 2 squared equals 4 times 4. But since our parabola is facing down, we want it to be negative. So it'll be negative 16 times y minus 3. For number 42, we want to write the equation of the ellipse in standard form. So the standard form of an ellipse looks like x minus h squared over a squared plus y minus k squared over b squared equals 1. So to get our equation to look like that, we're first going to write all of the x's next to each other. And write the y's next to each other. And then we'll move the 141 to the other side and make it a negative 141. Now we want to factor out a 4 from 4x squared plus 16x. And a 25 from 25y squared minus 150. And now we're ready to complete the square for both the x's and the y's. So if we complete the square for x squared plus 4x, we're going to add a 4 in inside the parentheses. And we're going to add a 9 in. And then, since we added a 4 in, but it's inside the parentheses, we need to multiply 4 times 4 and add a 16 to the other side. And since we added in a 9 and it's inside the parentheses and a 25 is on the outside, we need to add a 9 times 25 to the other side, which will be 225. So now we can factor. So we have 4 times x plus 2 quantity squared plus 25 times y minus 3 quantity squared equals 100. And finally, we want our ellipse to be set equal to 1, so we're going to divide everybody by 100. So our final answer is x plus 2 squared over 25 plus y minus 3 squared over 4 equals 1. For 43, we're going to do the same thing except we have a hyperbola, so we need to be conscious about the minus sign. And since y squared is written first, we're going to write all the y's together first and then the x's. So we have y squared minus 2y minus 4x squared minus 48x, and we will subtract the 59 to the other side. So now before we complete the square, we see that we can take a 4 out of 4 and 48, but I really want to pull out a negative 4. And we'll get x squared plus 12x. So now we're ready to complete the square, divide by 2 and square it. So I'm going to add in a 1 for the y's. Kind of pretend that they're in parentheses there. And I'm going to add in a 36 for the x's. So that means that on the other side of my equal sign, I need to add in a 1, and I need to add in a negative 4 times a 36, which will be a negative 144. So after we factor, we have y minus 1 squared minus 4 times x plus 6 squared equals negative 202. So now we want to divide by the negative 202. And dividing by a negative will switch the signs. So the x will actually become a positive, and the y will be negative. So when we write the most simplified version, we will have x plus 6 squared over 101 over 2 minus y minus 1 squared over 202, and that will equal 1. For number 44, we want to write the equation of ellipse given the following information. So we know that this ellipse has vertices at 2, 0, and 2, 4. And it has foci at 2, 1 and 2, 3. So we know that this is a vertical ellipse. And based on where the vertices and the foci are, we know that our center is at 2, 2. So we can already start writing out the equation of our ellipse as x minus 2 squared plus y minus 2 squared equals 1. And to get to our vertices, we have to go up on the y-axis 2. So that means that our a value is 2, and a squared will go underneath the y, and that is 4. We are not given our co-vertices, which would give us our b, but we are given our foci. And we know that the distance from our center to our foci is 1. So we know that c equals 1. So based off that, we can use our equation c squared equals a squared minus b squared. So we know that 1 equals 4 minus b squared. So b squared would have to equal 3. And again, we don't need to solve for b because we're just looking for b squared. So we know that a 3 will go underneath the x. For 45, we want to find the standard form of the equation of the hyperbola given the given parts. So for this hyperbola, we know that we have vertices at 2, 5, and at -4, 5. And we have foci at 4, 5, and at -6, 5. So, based off of this picture, we can find our center. Our center is going to be in the middle of our vertices. So, our center will be at -2, 5. And based off of this picture and where we know the center is, we can start writing the top of our equation. So we know this will be a horizontal hyperbola, so the x value will go first. So we have x plus 2 squared minus y minus 5 squared equals 1. A, again, is the distance between our center and our vertices. So the distance between -2 and 2 is 4. Oops, I realized I made a mistake. So the center should actually be at -1, 5. So we'll just scoot that over. And we'll change this to an x plus 1. And then that puts our a value at 3. So a squared will be 9. There we go. Sorry about that. So that is really an x plus 1. And then for our b value, we don't know it, but we do know our a and our c. C is the distance between our center and our focus. And so since our center is at -1 and our focus is at 4, we know that c equals 5. So we use the focus equation for the hyperbola, which is c squared equals a squared plus b squared. So 25 equals 9 plus b squared. So 16 equals b squared. So a 16 will go underneath the y minus 5. Just going to make the final equation look a little prettier. So we'll erase that and put a 1 there.